Hello everyone, my name is Christopher Royale of Stony Brook University. Today I will be discussing the use of supercontinuum light in fluorescence lifetime measurements. So a quick introduction into the topic. This is an electromagnetic spectrum. A supercontinuum laser produces pulses that contain wavelengths from 400 to 700 nanometers from what we call the visible light spectrum. For our purposes, we have a laser that generates supercontinuum light and is outputted through this fiber. This is what the light looks like when it is scattered. You can have a moment to be amazed. We want to use this light to activate fluorescence in a sample. By doing so, we can detect the changes in the nanoenvironment, the size of the molecules, the molecular interactions, and other things. Our goal is to create an efficient system in which to do this. Our experimental setup consists of a convex mirror to focus the beam, a cold mirror to allow the transmission of infrared light, which is then focused into an autocorrelator, a monochromator, a photodiode, and a constant fraction discriminator. The oscilloscope is used in tandem with the photodiode. The monochromator is a device that once entered the grating inside changes the angle and thus changes the wavelength of the outcoming source. We can select what wavelength we want. This then gets sent into the microscope to excite the sample through another series of collimation seen in the short video following. Before the laser enters the monochromator, we send part of the light to a photodiode. This starts the clock to measure the time between the excitation and the detection of one photon. Attached to the photodiode, we have a constant fraction discriminator. This is a small box that is very important because unlike other lasers which output the same intensity, the pulses of a supercontinuum laser are very random. This helps increase the accuracy of the lifetime measurement. Two things I was able to accomplish this summer was the completion of the whole experimental setup and the alignment of the laser into the sample. A large challenge faced along the way was with the constant fraction discriminator. The beam was not outputting what we were expecting. We wanted short pulses but instead got a long delay. A normal intensity profile should look like the first image, but instead we got something closer to the second image and the video here. All in all, I had a great summer experience at ENS Cachan and would like to personally thank Robert Ponceau, the University of Michigan, and you, the audience, for listening. Have a great one.